Welcome to Digital Forensics course. Previously, we have introduced data forensics, introduced the tools, explained file systems and evidence acquisition. We also noted the basics of networks. Now, we will try to focus on leave response. What we do during leave response is we first start by defining leave response. Then we will try to give a logical order of things you should check if you are thinking that one of your computers or one of your systems is under attack. First things first, let's start with what is leave response. Leave response is the action you do for forensics examination whenever you think that one of the systems is currently under attack or have been attacked and the evidence is still in the computer. I will give you a logical order about how one should react to such an attack. Most of the time we encounter with attacks. Most of the time we give leave response when we encounter attacks on commercial computers, so this is mostly a defense mechanism. This is mostly a protection issue. In rare cases, you would like to go and try to find the evidence from one of the criminal sites, even if you caught the criminals whenever they have their computers switched on, and so then you can try to check what is happening within this computer. In these cases, the first thing you should do if you are making a criminal investigation, if you are conducting a criminal investigation, the first thing you should do is it is better to receive an image of the computer's current memory as you do with hard disk images. We will come to that later, but having a memory image means that you actually have a perfect copy of the computer's memory, so actually you could check and try to understand the running state, the actual state of the computer at that given moment. Now let's switch back to the defensive actions. So imagine you are running your own computer system, you are running the network of the company you are working for, and you would like to understand if something is going on. So you are suspected that the computers are behaving interestingly, they go berserk, and there are lots of CPU actions, or they have a kind of general slowing down. So what you should do is first to check the network connections. How you can check the network connections? For example, you can use the IP command line utility in a Linux box, or you can use netview, netsession, netuse commands in a Windows box. So you try to understand what connections are made to your computer. If you caught an attacker at that stage, you see that there is an incoming connection and they are trying to send some commands or maybe some programs, applications to be installed persistently on your computer. Now you can see that. The other way around, you may think the other way around, if you couldn't catch the attacker at that very moment when the attacker is injecting malicious code or sending malicious commands to your computer, but just after that, very probably you will see that the attacker will try to make a connection from your computer to a centralized command and control center. This is very common because if you could manage to inject just a piece of small code that can that may enable the attacker to manage the computer communications, that it is very obvious that they will prefer to generate outgoing connections from your computer. The reason is, if you are making outgoing connections, it is very difficult for your firewall to catch and block them. Then afterwards, imagine that you have received a very first attack from the attacker. They sent just one comment, so you couldn't catch it, and then they generate an outgoing channel, and then they receive some executable to your computer. They downloaded some executable from some malicious sites without your notice. And then what will happen next is they would like to run this piece of software to do the malicious action. This could be a ransomware. They are trying, it may try to build a password protected archive of all your files. It may be just a Bitcoin miner. You can just mine Bitcoins for the benefit of the attackers and so on. So this could be anything. This could be, in general case, let's say a virus or a malicious software. So you need to understand what is happening there. In the next step, I advise you to check processes and the relevant libraries. To check that, you need to have some kind of familiarity with the actual processes of your computer. So maybe it is beneficial to keep a fingerprint of the programs or the actual programs running on one of your computers in a safe state, so you can just check the running processes every now and then, and also make the output of the programs and keep the output of the programs, so you can actually compare, and maybe if you can see a difference, you can easily pinpoint that one. And even if you have familiarity, and even if you see that all of the running processes seems adequate, there may still be some kind of attack that may be the attack may be hidden, because actually from a perspective of an attacker, they don't have any reason to name their running processes as malicious process.exe or something else. Most of the time they mimic operating system files like SVC host for services host for Windows systems, or some other very known and largely used binaries for Linux boxes. So it is better to check the processes together with their libraries. For example, you can use PS tool, or you can also use VMIC tool for Windows boxes, and you can see the running processes and also the relevant libraries. I say relevant libraries. The reason behind that is, when you check the processes, you may just see the process name or the command line that initiates this process, but these may seem adequate. But when you check the libraries, it is very possible that you can see an interesting library that's used in one of the, let's say, in one of the programs, one of the running processes. Imagine that you are running Microsoft Paint to draw something, and when you check the libraries, you see that it also makes SSH connections to some, or it's actually uses the SSH libraries. Then it is by itself suspicious. So Checking the libraries may reveal more information about the structure of the processes, so I always advise this. Then the next thing, imagine as an attacker, if you manage to run the process, you would like to organize the computer for your own benefit. For example, you may go and turn off the firewall for your future connections, or you may generate a hosts entry, or you may generate some kind of additional DNS server to route traffic. Actually, to see such things, you can. It is better to check the whole network configuration and see from the lower layers to upper layers to see if everything is correctly configured. If you are receiving a correct DHCP server address, if you have adequate DNS servers, if your firewall is working in enabled active state, and so on. After you do this, after you are ensure that you have the network configuration, you may also want to check the running services, because running processes are more visible than services, but services are mostly hidden from the end user, so you hardly see services as separate processes, or sometimes you have a pool that manages all services. You see just one process, and that service actually calls the relevant services. That process calls the relevant services whenever someone tries to use the service. Sometimes, for example, even keyloggers or some screenshot mechanisms could be installed as services, so it is better to check the running services. You can do this using command line utilities both in Windows and Linux boxes. For example, you can just use SC query for Windows boxes to see the running services. The next thing I will mention is the registry for Windows boxes and IPC objects for Linux boxes. There are some registry values that may be beneficial to be used for Windows machines. For example, there are keys in Windows registry that you can inject any command during the startup. For example, you can use run once or run once and execute. These registry keys, you can just inject any registry key any command into these registry keys, and these commands will be executed in the next startup of your computer. So this is one way of persistence for the attacker. You don't see anything else, and you just set up the registry, and whenever you start up your computer, you don't notice anything, but the malware is loaded and started to function. A similar idea could be thought for Linux boxes. They are not conceptually the same thing, but inter-process communication tools like shared memories or shared files. These objects could be used to gain persistence among other sessions after you boot. Some of the file descriptors may remain, and then using shared memories and so on, you can pass data in between processes and try to gain persistence. Another interesting point could be the environmental variables. The environmental variables are mostly overseen, but these variables affect the whole computer, the whole organization, and if you could inject clever tricks into this one, you can try to hide many things, and you can try to force the users, for example, the bash scripting, to do something together, to do something else other than the intended use of the user. Finally, one other way of persistency is scheduled tasks. You can check the cron jobs in Linux boxes. You can check the scheduled tasks through the graphical user interface or from the command line in Windows. And also, finally, you can go and check the file system to see if an awkward looking file exists in one of the critical directories. This is a very huge job to do manually, but if you have some critical directories, you may want to take a look at them. For example, the system32 directory for Windows machines, or binary or SPIN directories for Linux machines. A virus scanner may also ease your job at that stage. And finally, I would like to mention the event logs. This could be beneficial in the case if an attacker attacks the system, gains or not doesn't gain persistence in the system, and after transferring some of the critical data out of the computer, for example, copying or sending it to another computer or to an email address outside the network, then they may just initialize everything and leave no traces. In such cases, you can check the system or security event logs. For example, you may see in the event log that a user has been created and then this user has been deleted. So normally in your normal operation you don't see anything, but it is clear these kind of events are logged. So you see a random user has been created and then deleted, so you don't know what that user do during this time period. So it is better to check the event logs for suspicious events and try to take precautions for these things. Finally, I would like to go back to the memory images I mentioned in the beginning. If you have a memory image from a computer, there are other tools that may helpful for you to check the running processes, to check the network connections, and to check the current state and configuration of the operating system within that image. These are mostly separate tools, as you won't have a running computer when you have a copy of the memory, but there are tools that may extract such information directly from memory images. One example is the recall tool. So you can check the number of connections, the target and source addresses, or the list of running processes directly from the memory image. You don't need to go through the whole image by yourself manually, and it's obvious that you cannot just copy the memory to another computer and try to run this from scratch. This will be a lot of job. So finally, as I said, there are a separate set of tools for memory images, but your behavior should be more or less the same with the leave response. Now you have more time to investigate in detail if you have the memory image. That's all for leave response lecture. See you in the next lecture. Goodbye.